Hey Jenny, welcome back to the podcast. Ready for another deep dive into the wild world of tech?
Mark, always. Especially when we're tackling something as, well, fundamental as the future of computer memory. I've been hearing whispers about SRAM hitting some roadblocks.
Whispers? More like a sonic boom. We're talking about the potential death of traditional computer memory scaling as we know it. Sounds dramatic, I know, but the implications are huge.
Okay, death is a strong word. Lay it on me. What's causing this? Memory apocalypse?
So basically, SRAM, static random access memory, it's the super fast memory that your CPU uses for its cache. It's been shrinking along with other components. Following Moore's law, getting smaller and faster with each generation.
Right. The good old chips get twice as fast every 2 years thing.
Exactly. But we're hitting a wall. A physical wall. Below 3 nanometers, SRAM cells are becoming unstable. It's like trying to build a house of cards in a hurricane.
That sounds problematic. So the individual memory bits are just too small to work reliably?
Precisely. It's all down to physics. Things like random dopant fluctuation and line edge roughness. I can get into the nitty-gritty if you want. But the short version is, shrinking SRAM further is causing all sorts of electrical problems.
Save the nitty-gritty for your blog, Mark. I trust you on the physics. What I'm curious about is the impact. What does this mean for, the average computer user?
Well, think about it this way. If SRAM can't shrink, but everything else times can, then SRAM starts taking up a bigger and bigger proportion of the chip. It's like your kitchen suddenly doubling in size while the rest of your house stays the same.
Okay, that's a great analogy. A giant, power-hungry kitchen hogging all the space.
Exactly. And that means higher manufacturing costs, up to 45% higher according to some reports. Fewer chips per wafer, and each chip is more expensive to make.
Ouch. So, pricier processors, less powerful, and potentially shorter battery life for our laptops and phones?
You got it. It's a triple whammy. It's not just about the high-end stuff either. This affects everything from servers to smartphones.
So what's the solution? Are we just stuck with these giant, expensive, power-hungry chips forever?
Not necessarily. This is where it gets really interesting. The industry is exploring some seriously cool alternatives. One of the big ones is 3D stacking.
3D stacking? Like building chips upwards instead of outwards?
Precisely. Think of it like building a skyscraper instead of a sprawling suburb. You can pack a lot more cache into the same footprint. AMD's 3D cache is a prime example. They're seeing some impressive performance boosts with it.
So they're essentially layering the cache on top of the processor?
Yeah, using something called hybrid bonding. It creates incredibly fast connections between the layers. We're talking terabytes per second of bandwidth. It's like having a superhighway directly to your memory.
That sounds impressive. But is 3D stacking the times-only time solution? What about completely new types of memory?
Oh, that's where the asterisk really futuristic stuff comes in. We're talking about things like FRAM, ferroelectric RAM, and MRAM, magnetoresistive RAM.
Those sound like something out of a science fiction movie.
They kinda are. The basic idea is that they use different physical principles to store data, not relying on tiny electrical charges like SRAM. This means they can be much smaller and potentially much more power efficient.
So they could potentially replace SRAM altogether?
In certain applications, yes. Especially where you need non-volatility, meaning the memory retains data even when the power is off. Think of things like embedded systems, IoT devices, maybe even some parts of data centers.
But are these new memories as fast as SRAM?
That's the trade-off. Right now, they're generally not quite as fast for asterisk all times operations, but the gap is closing. And for some specific tasks, they can actually be faster and times use less power. It's all about finding the right tool for the job.
So it's not a one-size-fits-all solution. It's more like a memory toolbox, with different types of memory for different needs.
You nailed it. And the big players like TSMC and Intel are heavily invested in this. TSMC's N2 process, for instance, is showing some promising improvements in SRAM density, even if it's not the huge leaps we used to see.
And Intel's been talking about their own breakthroughs, right?
Yeah, it's a bit of an arms race at the moment. But beyond just squeezing a little more out of SRAM, we're seeing a shift towards chiplet architectures.
Chiplets? Explain that one to me.
Instead of building one giant monolithic chip, you break it down into smaller, specialized chiplets. One for the CPU cores, one for the cache, maybe one for the graphics. Then you connect them all together using advanced packaging techniques.
So it's like a modular design for chips?
Exactly. It gives you more flexibility, and it can help with the SRAM scaling problem because you can optimize each chiplet individually. You can use a more advanced, expensive process for the logic and a less advanced, cheaper process for the SRAM.
That makes a lot of sense. So, what's the long-term outlook? Where do you see all of this going in, say, 5 or 10 years?
I think we'll see a much more heterogeneous landscape. We'll have a mix of traditional SRAM, 3D stacked cache, and these new emerging memories like MRAM and FRAM all working together, and chiplet designs will become increasingly common.
So the future of computer memory is diverse?
Precisely. It's not about one single technology winning out. It's about a whole ecosystem of memory technologies working together to give us the best performance, power efficiency, and cost. It's a fascinating time to be in tech, Jenny.
I agree, Mark. It sounds like we're on the cusp of some major changes, and it's going to be exciting to see how it all unfolds. Thanks for breaking it all down for us.
Anytime, Jenny. And to our listeners, thanks for joining us on this memory lane journey. Did I get it? Times laughs.
Groans playfully. Oh, Mark. Always with the puns. But seriously, folks, this is a topic to keep an eye on. It's going to impact everything from the phones in our pockets to the supercomputers powering scientific discovery.